Hi, my name is Madhusudhan. I'm studying BTech in B.I.T. University. Now I'm gonna discuss about floating point, adder, subtractor, and multiplier using Verilog, which is a digital assignment in the course called Computer Organization and Architecture. Floating point. The real numbers represented in binary format are known as floating numbers. Based on IEEE 74 standards, floating point formats are classified into binary and decimal interchange formats. Floating point multipliers are very important in DSP applications. This paper focuses on double precision normalized binary interchange format. Floating point implementation on FPGAs has been the interest of many researchers. The units are fully IEEE compliant. The double precision add and multiply achieved the operating frequency of 230 MHz using a 10-stage adder pipeline and a 12-stage multiplier pipeline. So therefore, we a lot of similarities between the selected paper related to computer organization and architecture syllabus, as we have already learned somewhat about similar kind of topics from the modules of our COA curriculum. Um, this is a tabulation form for area and operating frequency of double precision floating point, adder and subtractor and zealot core. This is a tabulation form for area and operating frequency of double precision floating point multiplier, single precision floating point multiplier. This is the tabulation form for device utilization summary of double precision floating point, adder, subtractor and multiplier. This is a tabulation form for timing summary of double precision floating point, adder and subtractor and multiplier. And this is a black box view of double precision floating point, adder and subtractor. We can observe clearly in this picture. And this is the block diagram of double precision floating point, adder, subtractor, which is drawn in draw.io software. This is the block diagram for multiplier structure with rounding and expectations. This is a link where we can find this diagram, which is drawn by me. This is the black box view of floating point double precision multiplier. Last time I have shown this as double precision floating adder and subtractor, and this is for multiplier. This is the block diagram for interconnections of submodules of double precision floating point adder and subtractor. Now let's discuss about the differences comparison between proposed architecture and the existing architecture. In proposed architecture, increased power efficiency, whereas quite opposite for existing architecture, there is not much increase in power efficiency. Low power consumption in proposed architecture, reduced delay, boost in performance, more preferable portion of this kind of workflow. Totally, these differences are very sorry. When compared to the existing architecture, proposed architecture is very useful for us. And these are the advantages of the proposed design over existing design. Advantages are increasing power efficiency, low power consumption, reduced delay, boosting performance. This is most more preferable portion for this kind of workflow. These are the list of merits and demerits of the proposed and existing techniques and hardwares. Merits are power efficiency increases, low power consumption, reduced delay in operations, perform boost. When it comes to demerits, complex circuitry, increase in the size of the chip. Nowadays we are more interested in very small size of chips. These are the list of applications proposed in proposed design. Multitasking, adding the exponent of two numbers, then subtracting the bias from the result. Multiply the significant of two numbers. CPU design is divided into design of the following components: data pads, control unit, logic which controls the data paths, and memory components such as register files, cache, clock circuitry such as clock drivers, PPLs, clock distribution networks, pad transceiver circuitry, logic gate library which is used to implement the logic. The data paths. And the last slide is about the flow chart of this what we call floating point adder, subtractor and multiplier. Let me show how I draw this using the online website called, wait a minute, yeah, we can simply type draw.io. Then it goes directly. If we create an account for this, then whatever the work we did in this software, directly it will get saved in our drive. Let me show a small flow chart how to draw in this website. Let's clear all this. We can save with the name whatever we want in this. Let me save as flow chart. Let's have a small flow chart. We can select and we can give wherever we want. We can change the size of this, we can increase it. We can also copy this if we want. Press Ctrl plus C and we can paste it again. We'll get how many diagrams we want. We can copy paste it. Let me take one more. Let's have a small flow chart. Okay, we can also drag it. We can also press and we can also click and get it. We can also drag it. So it's just like it. Okay. So here click on this block, so we can able to write something whatever we want. Let me write start. Okay, let's draw fully first. Based on our requirements, we can drag whatever the block we want. Here I am showing just a small example how to draw in this website. Okay, so now we can click on it and we can write whatever the condition we want. Let me say something condition B, B, C. So if the condition is true, then it goes directly to D. We can also increase the size of this text. Double click on this and we can increase whatever the size we want. And we can also change the style of the text. Let's have nothing across and ending part. You can write end. So when it is true, then the condition, if the condition B is true, then it passes to B, then it passes to C. Then again it goes back to B. We can do like this. Okay. This so it goes on iterating till the condition gets false. Then after waiting for the condition gets finishes. We can write some text called condition, let's say false. We can increase the size whatever we want, whatever style we want we can use it. So this is how we can save this. So now actually I did this using opening my account. So if I go and check in my drive, we can see that whatever the work we did in that draw.io software, we can see here. See, like that whatever the work I did, everything gets saved in our drive. We can use wherever we want. Thank you.